Dear students, in this video lecture, we are going to discuss Module 6 of Basics of Mechanical Engineering. And this module is all about different types of manufacturing processes. And in this section, we are only dealing with casting process. So I would like to give an introduction about manufacturing and manufacturing processes. So the word manufacturing, it is originated from a Latin word manufactures, and its meaning is made by hand. So the manufacturing is defined as the production of finished products or finished components. So finished products or finished components are the product with defined geometric shape and defined size which satisfies human needs. In this figure, you can see that the raw materials is going through a certain steps, and then it is converted into a output. Okay, and those steps through which raw materials are transformed into a final product are known as manufacturing processes. And by these manufacturing processes, actually we are adding some value. For example, you can see a lump of mild steel which does not possess any values. Then it is converted. If you apply the manufacturing process into that, it is converted into a useful product, bolt. Bolt is very useful. Okay, that is the importance of manufacturing. And there are different types of manufacturing out there, and now we can classify manufacturing processes. So going to the classifications of manufacturing processes, the first one is shaping process. What is this shaping process? In shaping or forming process, we are not removing any material. Instead, the examples are casting, forging, rolling, extrusion. So in the casting, we are not removing any material for the final product. Here we are melting the metal and pouring it into a cavity. The cavity is having the shape and size of the final product, and we will allow it into solidify, and we will get the final product. In the case of forging, rolling, extrusion, we are applying some force into the raw material, and we will deform it, and we will convert it into the required shape. Okay, and second one is machining process. Here we are using some machines to remove the material, and then we will get the required shape. So examples are turning, milling, drilling, and grinding. So all these operations require a particular machine, and those machines are known as machine tools. And now the third one is joining process. Here two or more metals parts are joined together by operations such as welding, brazing, soldering, etc. And the fourth category is surface finish process. Here the required surface finish or protective coating is provided. This process is used to provide required surface finish or protective coating, and examples are electroplating, coatings, etc. And the fifth one is property modification process. If you require to achieve any desired property, or if you require to modify any particular property, you can utilize this process. And examples are tempering, annealing, hardening. So if you want to increase the hardness of a particular material, then you can go for this hardening process. So these are the different types of manufacturing processes. So in this module, we are focusing on casting, forging, rolling, extrusion, which is coming under shaping processes, and turning, milling, drilling, and grinding, which is coming under the machining process, and welding, brazing, soldering, which is coming under the joining process. So all these processes will be learned in this chapter. Okay, now we are going to discuss about casting. So what is casting? Okay, casting is a manufacturing process by which a molten material, usually metal, is poured into a mold which contains a hollow cavity of the desired shape and then allowed to solidify. So in the figure also you can see that a molten metal is poured into a cavity. The cavity is in the shape of the final product, and we allow to cool it, and we will get the final product. Okay, and now we will discuss the different applications of casting process. So the casting process is having different application in many field. So in automobile field, engine blocks, cylinder blocks, pistons and piston rings, in machine tool beds, frames, mill rolls, and in water supply, sewer pipes, sanitary fittings, agriculture parts, all are made by casting process. There are many applications. Okay, now what are the basic steps for this manufacturing process casting? The first step is we have to prepare the mold, and simultaneously we have to melt the metal. Then pour this molten metal into the mold and allow the molten metal to cool or solidify in the mold, and after that remove the solidified component from the mold. So that is the steps of casting. So we are going to discuss the mold preparation in detail. So how we can prepare mold. So mold preparation. So before that, what is mold? Mold is defined as the negative print of part to be cast. For example, you can see a cross-like structure. That would be the final product. And in order to get that, the cavity, the same shape of cavity we have, the cross-like shape of cavity we have. So that is the mold we require, the cross-like structure cavity. So that is why it is told that the negative print of the part to be cast. Mold is defined as the negative print of the part to be cast. If you require a solid cross-like structure, then we require the mold as a cavity which looks like a cross structure. Okay, and the process. Okay, the process of making the mold is known as molding, and the mold is mainly made of heat resistant material, and a well known heat resistant material is sand, and here we are calling it as molding sand, and it consists of a mixture of silica sand, clay and moisture in appropriate proportions. This molding sand is having different properties which is well suitable for a preparation of a mold, such as its permeability, its refractoriness, that is the ability to withstand high temperature, and its fineness. There are many properties which makes the sand suitable for mold preparation. And in a process in which sand is used as the molding material, or the casting process characterized by using sand as the molding material, then it is known as sand casting. Okay, now we are only discussing about sand casting. There are many other casting. Metal casting is there. There are many types of castings are there, but we are only discussing sand casting. So for the discussion, we should know about certain terminologies which is related to sand casting. The first one is flask. The flask is a metal or wood frame without a fixed top or bottom. That means top and bottom are open, in which the mold is formed. We are going to make the mold within this flask. So flask is categorized into two. The lower molding flask is known as drag, and the upper molding flask is known as cop. So in this figure you can see cop and drag. So we can fix it together with a pin. We can fix it together. The lower molding flask is known as drag and upper is known as cop. Next is pattern. It is the replica of the final object to be made. It is a kind of duplicate. The mold cavity is made with the help of pattern. So this is the pattern. So what would be the final product? The same thing. Okay, the pattern can be made by a different material. For example, you can see a rod. Here, this is the final product. But the replica or pattern is made by another material. And this is the cavity which is formed using this pattern. Okay. Next is, if you are fixing this cop and drag, and if you are fixing the pattern in that, it would be look like this. And you can see this is the molding board, and above the molding board we can fix our drag, and above the drag we are having our cop which is fixed together by a pin, and we place we place pattern here. This is the pattern. Okay, and using that pattern we can create a cavity on that, and into the cavity we have to feed the molten metal. So for that we require certain parts. The first one is pouring basin. It is a small funnel shaped cavity at the top of the mold into which the molten metal is poured. So this is the pouring basin. It is a small funnel shaped cavity at the top of the mold into which the molten metal is poured. And from the pouring basin, the molten metal passes to sprue. The passage through which the molten metal the passage through which the molten metal from the pouring basin reaches the mold cavity is known as sprue. It controls the flow of metal into the mold. This is sprue. Okay, the arrow is, this is the sprue. And from the sprue, it will go to the runner. It is a channel through which the molten metal is carried from the sprue to the gate. It is known as a runner. And from the runner, it will enter into the cavity through the gate. Okay, and there is a separate column is provided, which is known as riser. What is the role of riser? So when we are filling the cavity with molten metal, we will fill the molten metal up to a certain point in the riser. So when it, after the solidification, the casting will shrink, and in order to compensate that, the molten metal will flow from the riser into the cavity. So that is the use of riser. Okay, and because of that, it is also known as feed head. And you can see a parting line. This is the dividing line between the two molding flasks that makes up the mold. You can see this as the parting line. Okay, then vents are provided. The small opening in the mold to facilitate the escape of mold gases. For escaping the mold gases, we will provide some vents. So you can see the vents here, here, here. Okay. Now this is the arrangement. We are pouring the molten metal through the pouring basin. Then it passes through the sprue, then it will go to runner. From the runner through different gates, it is entering to the casting. Simultaneously it is entering to the casting, and we are filling up to this level of riser, and once the casting solidifies, it will shrink, and in order to compensate that, the molten metal further flows down from the riser. So this is the arrangement. Okay, and okay, now core chaplets. Okay, in this figure, if you require to create an opening with and various cavity shaped in castings, so this is the final product, and inside you can see I have to create a cavity. So I have to create a cavity inside the final product. For this purpose, I use core. So core is made by sand. So this is the core, and in order to support that core, I have my chaplets here. And once the molten metal passes through the chaplets, it will melt together with the molten metal, and then it will the molten metal is filled. Here it is filled, and we can create the cavity inside the final product. That is the use of core, and in order to support the core, we have chaplets. So these are all terms which is related to the castings. Now we are going to discuss about the steps in green sand molding. How we can prepare a mold with a green sand. The first step, the pattern is placed on a molding board. Okay, you can see that we place the pattern above the molding board, and the drag boss is placed around the pattern. You can see this is the drag boss. We are going to place it around the pattern, and next step is drag boss is filled up with green sand. Okay, you can see we place the pattern on the molding board. Above that we place the drag box. Now we are going to fill it with green sand, and after that we are going to ram it. Okay, ramming is done by a rammer. We rammed it properly, and once the ramming is over, the excess sand is removed by a strike of bar. We are removing the excess sand by a strike of bar. And next step is the drag boss is tilted upside down. Okay, it is tilted upside down. In the beginning it is below the drag box, and in the sixth step we tilted upside down. Now it is above the drag box. Then we will provide some parting sand. We applied some parting sand upper side of this drag box to prevent sticking to the cork box. Okay, next is the eighth step is the cork box is placed correctly in position on the drag box. So just above the drag box we are placing the cork box. Okay, cork box is placed correctly in the position of drag box. Okay, same thing, and we will using the locating pin we will fix it to there. And then we are having the sprue pins and riser pin. We are place it correctly in position, and in next step cork box is filled with molding sand and ram it. Okay, so now inside the molding sand we can see our sprue pins. And the next step we are removing the sprue pin and riser pin, and we will also provide provision for vent holes. Okay, now you can see this is the sprue pin and this is the riser pin, and in this step we are removing it, and you can see this is our cavity. This is our cavity. Okay, now the cork box and drag box are separated. The patent piece, okay, not this is the cavity, not this is the cavity, this is the patent. The cork box and drag box are separated. The patent piece are removed slowly. So we just separate the cork and drag boxes, and the patent piece is removed using this hook. We are removing the patent from the cork box. Next step, the runner and gate is cut on the drag. Okay, this is the we are making a connection between this sprue and cavity. So we are runner and gate is cut for in order to flow the molten metal correctly into the cavity. And in the next step, the cork and drag box are assembled in correct position and lock it. And now our mold is ready for pouring molten metal. The inside we have a cavity, and riser is provided. If it shrinks, it will compensate it. Now we are already having the molten metal ready, and we will pour the molten metal into the mold cavity space through the pouring basin, through the sprue and through the runner. Once it is poured, we will wait for some time and allow it to cool and solidify, and after that we will break the mold and we will take out the component, the solidified component, and these two will be removed, and we will do some surface finishing operation if it is necessary, and we will get the final product as this. Okay, this is riser one, this is sprue. Okay, this will be removed, and this is the final product we are getting. Okay. Okay. Okay, this is the okay, sorry. Then we are going to discuss about sand casting advantages and disadvantages. The first we are going to discuss about advantages. The production process is very simple. Even in workshop also we are preparing this mold, and I think it is already included in your syllabus, and you will learn it in the workshop. This is included, the mold preparation using sand is included, and the production process is very simple. The cost of casting is very low, and the sand can be reused. is having good durability, so it can be reused. And disadvantages are defects. Chance of defects are more in the case of sand casting. And it does not impart a good surface finish. For the surface finish, we have to do machining later. Even though it is a cast product, we have to go for a machining process after finishing the casting. So these are the advantages. Then I can just list down some of the casting defects just for your information. The first one is blowholes. It is the holes below the surface of casting, not visible from outside. And next is inclusion. Foreign materials, in the inclusion of foreign materials in the casting. You can see foreign materials included in the casting. And next is scab. It is the erosion or breaking down of portion of the mold. And next is honeycombing. A small cavity is present on the casting surface. And next is misrun. If in some cases the molten metal fails to reach all the section of the mold, you can see it comes only up to this point. So this is known as misrun. And next is localized enlargement of the casting. And the shift, next is shift. It is the mismatching of products, I mean casting sessions. It is mismatch, not matching. This is the matched one, this is the mismatched one. So these are the casting defects.